solving geometric problems. The points A, B, C and D have coordinates 1, 3, 2, 3, -1, 5, -1, 9, 1 and 3, 1, 7 respectively. Show that A to B and C to D are parallel and CD is 2 A to B's. So we need to go from A to B. To do that, we do B take away A. So A to B is going to be our B, which is 3, -1, 5. Take away our A, 1, 3, 2. So let's take them away. 3 take away 1 is 2. -1 take away 3 is -4. And 5 take away 2 is 3. The same for C to D. So C to D is going to be D take away C. So 3, 1, 7 take away -1, 9, 1. 3 take away -1 is 4. 1 take away 9 is -8. And 7 take away 1 is 6. So we can see they're parallel. That's because one is a multiple of the other. So they are parallel. And the reason is, well, what we already know. The reason is because C to D is equal to 2 A to B's. Hence describe the quadrilateral ABCD. So we've got a set of parallel lines and one's twice the length of the other. So whenever we've got two uneven parallel lines, we have a trapezium. So it's a trapezium. One question for you to try, see if you can give it a go. So again, we need to show that AB and CD are parallel. So to go from A to B, we do B take away A. So 1, 6, 3. Take away 4, 1, 5. So that's -3, 5, -2. So that's A to B. And for C to D, we do D take away C. So 2, 4, 1. Take away -1, 9, -1. So we get 3, -5, 2. And that is C to D. So we can see that they're parallel because C to D is equal to a -1 times A to B. Or we could even say, because A to B, if we went backwards, A to B would be equal to D to C. So A to B is the same as D to C. They're equal. So they are the same line, they're parallel lines. And they're also equal in length. And that's important for part B. Describe the quadrilateral. So we've got parallel lines, but they're equal this time. Like so, it makes a parallelogram. Another question. This time we've got 3 points, A, B and C. And we need to show that the triangle ABC is isosceles. If it's isosceles, it should have 2 equal lengths. So let's find the lengths of AB, BC, and AC. So the length of AB is going to be Pythagoras. So from A to B, how far do we move? So it's 4 in the X direction, 2 in the Y direction, and 3 in the Z direction. The signs don't matter. Because we're squaring them, they're all going to be positive when they're squared. So we want the square root of 4 squared plus 2 squared plus 3 squared. So square root 29. for B to C. How far do we move to get from B to C? So it's 4, 2, and 3. So that's square root 29. And A to C. So it's 0 in the x direction, 4 in the y direction, and 0 in the z direction. So that's square root 16, which is 4. We have an isosceles triangle. 2 sides equal, therefore isosceles. Find the area of the triangle. So we've got a base of 4. Let's do a little sketch. So a base of 4 and 2 lengths that are square root 29. How can we find the area? Probably the easiest way is to make it into a right angle triangle. So we have a base of 2. We don't know the perpendicular height, but we can find it using Pythagoras. So it will be h squared plus 2 squared equals square root 29 squared, which is 29. So h squared is 25, so the height is 5. So the perpendicular height is 5. So the area of the triangle is half times the base times the height. So it's 10 units squared. Find the point D such that ABCD is a parallelogram. So we have 3 points already that make an isosceles triangle. So A to B and B to C are square root 29, and A to C is 4. We need another point that makes this into a parallelogram. So we could put a point over here. We could also put it on this side. Either one of those. So what we want to do is find the distance from A to C. How far do you move to get from A to C? Which is 0 in the x, 4 in the y, and 0 in the z. And we want to do that same movement to our B coordinate. So let me just write that down. I write A to C is 0, 4, 0. So if I do that translation to B, what do I get? I'll get 7, 7, 5. So D can be 7, 7, 5. So add nothing to the x, add 4 to the y, and nothing to the z. And one question for you to try. See if you can give it a go. So the points A, B, and C have coordinates 3, 1, 2, 3, 1, 6, and 5, 3, 4 respectively. Show that the triangle is isosceles. So it's going to have 2 equal sides, 2 equal lengths. So let's go from A to B, or the modulus of A to B. What's the length from A to B? So we've got 0 in the x, 0 in the y, and 4 in the z. So it's 4. B to C, we have 2 in the x, 2 in the y, and 2 in the z. So we've got square root 12, which is the same as 2 root 3. And A to C, we have 2 in the x, 2 in the y, and 2 in the z. So again, square root 12, 2 root 3. So we've got two equal sides, two equal lengths. Therefore, it's isosceles. Find the area of the triangle ABC. So we have a base of 4 and 2 square root 12s. So let's find the perpendicular height, splitting it in half to make a right angle triangle. 2 squared plus h squared equals root 12 squared. So h squared is 8, h is square root 8. And then the area is half times the base times the height. So it's 2 square root 8s or 4 square root 2s. 4 square root 2 units squared. And part C, find the point D such that ABCD is a parallelogram. So again, we've got 3 points that make an isosceles triangle at the moment. And they are, so A to B was our base. We want another point, so we can either go to the left of C, so do the movement from B to A to C, or to the right of C, which would be the movement from A to B onto C. So to get from A to B, we move 0, 0, 4. So we're going to do that same movement onto C to get D. This is C at the moment. We're adding 0 onto the X, 0 onto the Y, and 4 onto the Z.